let's take a look at, so if you remember, I asked page 47, 48 that you could turn in today. Is there anything on page 47, 48 still that you would need to go over?
28.
Which one? 28? Yeah, all right. All right, number 28, we got, they told us the area of this is this. Excuse me. And then on this rectangle, we know that this is 3x and we don't know what that is. Okay, so let's see. The area of the rectangle is given by that equation. If one side is 3x, which is given, what is the other side? Okay. So area of a rectangle is length times width, I believe. Do you agree with that? Okay. So we have to approach this maybe by looking for a greatest common factor amongst our area equation. What do you think? So if I break this up, this is 2 times 3 times x, and then this is just 3x and x, and then 12 is 2 times 6, and 6 is 2 times 3, right? And then there's an x there. Let's just double check that I did this right. 2 times 3 is 6, x is x to the third, 3x is 3x squared. Okay, 2 times 2 is 4 times 3 is 12 times x. Yep, so that's correct. So is there something that I can cancel out of each of those? Take a look at all three of those terms that I wrote in red. I'll dim the light so it makes it a little nicer. What do you think? Yeah. Okay, there is a 3 in common on all three of those terms. I agree. So I have this one, and this one. Is there anything else that's in common with all three of those? Yeah. There's a 2 here, but there's not a 2 here, right? So I can't factor that out. Anything else the same in all three? Yeah. X, yeah. So I got this x, and this x. So if I factor all of those out, that's 3x comes out front. So if I factored 3x out of this, what do I have left? 2x squared, awesome. If I factor a 3x out of this, what do I have left? Just an x. If I factor a 3x out of this, what do I have left? 4. And notice I'm keeping those signs. So now, they told us, so we know that length times width is the area. They told us the area was this, but then they told us one of our sides was 3x. They gave us this, right? Well, is that and that the same thing? Yeah? So length times width, this is the width. Is that okay? That's a little tricky. You will not see that on a test or quiz. That's just a little trickier. Agreed? Okay. Anything else from that page 46 and 47, or 47 and 48? Some of you had already turned it in, so you're good on it.
You can probably do 22 and 24.
Which one do you want? 27, and you say what?
22 and 24.
22 and 24. All right. 22, 24, and 27? Yeah. All right. 10x squared y to the third plus 12x to the third y squared. Okay. So let's go through. 10 is the same thing as 2 times 5. And then x, y, y, y. That's the same thing. Agree? Just broke down into its parts. Plus sign comes down. 12 is the same thing as 2 times 6. 6 is 2 times 3. And then x, y, y. Okay? Everyone feel comfortable with that so far? So let's see what we have in common. I have a 2. I have a 2. I have a 5. I don't have a 5, so that's it. I have an x. I have an x. I have another x. I have another x. I have a y. I have a y. I have a y, and I have a y. So what I have in common between these is 2x, x, y, y. So I have 2x squared, y squared. That's what I have in common. If I factor that out, what do I have left here? 5 and a y. That plus sign comes down. If I factor all those out, what do I have left? 6x, yeah, done. So you're undoing distributing, right? Feel comfortable? This is a nice board. This is a real nice board. Tell you what, we might move down here for good. No, I'm just kidding. Yeah. Yeah. Let me do 24 first, and then I think 27, and then you said 26? Okay. Let's see. Let's break everything up on this one. So I know that 14 is 2 times 7, and then I have an A, then I have a B, and a B, plus 21 is the same thing as 3 times 7, and then I have an A, a B, and a B. So those are all broken up. So let's mark up what we have. Let's see, I have a 7 and a 7, an A and an A. I got these two B's and these two B's. So that means that 7AB squared is the greatest common factor. I have a 2 left here, plus I have a 3AB here. Done. .7 x4 y3 z5 plus x squared y5 z3. So we just got letters. Okay. So 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. Plus 1, 2, 1, 2, 3, 5. 1, 2, and 3. Does that look okay? Kind of looks silly going that far out, but you know, if you get the right answer, you'd be all right. So what's the maximum number of x's I have between the two? 2. I have 2 of them. So these 2 and these 2. Still with me? Maximum number of y's I have between them? 3. So these 3 and these 3. Maximum number of z's? 3. Those 3 and those 3. So I have x squared, y to the third, z to the third in common between them. That's my greatest common factor. I'm left on this one with xx, zz, so that's x squared, z squared, plus y squared. Done. Last one was what? That was it? I already thought someone asked for one other. All right, so let's do this. Will you, if you did not turn in page 47 and 48, some of you got it back already, so I don't need it back. Your grade's already in. So if you have 47 and 48 done, will you pass them up, please? And then would you get out page 49 and 50? Do not pass 49 and 50 up yet. Let's take a look at page 49. Page 49. Any questions on problems 1, 2, or 3? 1, 2, or 3 on page 49. I have a front open. You are good to go. Thank you.
The only thing is, it's right in front of the computer and stuff.
You'll be okay. Any questions up through number 6 on page 49? Get your butt out.
It's colorful.
Any questions on up through number 13? See a couple phones out. Let's put them away. 11? Thank you. Number 11. 6x minus 6y plus 4x minus 4y. Okay, so when there's 4 terms, we are going to go through this process. And this is a huge process for you all to start seeing because it's going to relate to today's too. So what I'm going to do, if I have 4 terms, I'm going to look at the first 2 terms. What do I have in common between those first 2 terms? They both have a 6, and then that leaves me x minus y. Is that okay so far? Then I look at these right here and take a look. Do I have anything in common between those 2? A 4. So it's going to be a positive 4. Whatever this sign is right here, this sign will come down here. So it's a negative it also. So if that stays positive, no signs change. So then take a look what I have. Okay? What do I have in common between the purple and the green now? Good, have an x minus y. Good. So they both have here and here. So I have x minus y. And then I'm left with 6 plus 4. That's kind of funny because the 6 plus 4 is just 10, right? Yeah, that's kind of goofy that I goofed up like that. But hey, oh well. Anything else up through number 13 on page 49?
6.
6. All right, I have 3x, then 2x plus 5y. Then I have, found us, 2b, and then 2x plus 5y. That's how you came in. You have a late. You're good. And you can sit wherever you want. All right. B. Do we have that and that the same on both?
Yeah.
Agree with that? So I'm going to factor that out. Whatever I have left, I'm just going to rewrite in another binomial, and it's done. That's it. Done. Anything else up through number 13 on that page? Yeah. 13. You got it. 4x to the third plus 2x squared plus 6x plus 3. Okay, so if we have 4 terms, it's going to be the same every time. We're going to look at the first 2 terms, and we're going to say, hey, what do we have in common between those 2? And I could factor a 2 out and an x squared. What do you think about that? And I'm not writing it all the way out, so I think you should start saying it. So if I factor that out, that means that this is the same thing as 2x. Because think about it. 2x squared times 2x is 4x to the third. Agree? And then if I factor a 2x squared out of here, I have to have 1 as a placeholder. Okay, so that's that part. This sign has to match here. Looks like I can factor a 3 out. And that would be then 2x plus 1. Now, hang on. Before you're sitting there go, wait, how'd that happen? 3 times 2x is 6x, and 3 times 1 is 3. Right? So now I have this binomial the same on both. So I have 2x plus 1. And I'm left with this and this, so I just make that a new binomial next to it. Done. Page 50 on the back side. Do what?
So you think you give us an extra day on this one or no?
Sure, I'm happy to. Happy to. Yeah, absolutely. Page 50. 14 through 20. Any there? There was one that I think is a misprint. I just don't know. I haven't seen it yet. I don't know where that went. What? Yeah. 20? 18 is a misprint? Oh, on yours? Oh. Okay. Okay. 4 terms, yes? So with those 4 terms, what we're going to do is we're going to say, hey, what do I have in common between these? Looks like I can factor an x squared out. That leaves me x here minus 2. Does that make sense? Because x squared times x is x to the third. X squared times negative 2 is negative 2x that, right? Then I'm going to look here. Remember I said this sign has to match right here. So I'm factoring out actually a negative 4. So I factor a negative 4 out, it's going to leave me just x. Think about it. Negative 4 times x is negative 4x, right? So negative 4 times what would give me positive 8? Negative 2. Look how that sign just changed. Okay, think about it. Does that make sense? Negative 4 times negative 2, positive 8. Does that make sense? I have this and this in common, so I have x minus 2. And then whatever I have left, I'm going to make it as a binomial. We'll keep that good. Yeah?
How you put x minus 2 on the left side, instead of you doing all of that, like trying to figure out how many times it goes to 8, can't you just copy it over and put x minus 2, or is it possible that it won't be
So the step that I stopped doing is this.
Yeah.
I was doing that. So we're just moving down from there. So that's basically all that's taking place. Okay, if you need an extra day on this, page 4950, please by all means take it. If you feel comfortable with what you have, come put it here on this folder up here.
Right, this would be on Monday.
Yeah, if you need the extra day, take it. No penalty.
Where do I put it when it's turned in?
Right there.
One.
2. That was almost a good shot. All right. So, guys and girls, you got to trust me. I can get through this. There's a reason I record these things. Okay? So we're going to be undoing factoring. Meaning, let me slide back here, very front. Okay, so if I were to factor, or if I were to multiply this out, I would have to go here, here, and here, here. That gives me x squared plus 3x, and then here, here, and here, here, which is plus 4x plus 12. Hey, take a look what that is right now. How many terms are up there right now because I multiplied it out? 4. Okay, so that's what we're going to be getting to eventually. Now, if I wanted to put this back together, I would put my like terms, so I get x squared plus 7x plus 12. That's my answer because 3x and 4x. But take a look how that's 4 terms. Okay? That's happening for a reason, and that's what we're going to start focusing on. If I multiply this one out, I get here, here, and here, here, so I get 6x squared plus 10x, and then switching colors, here, here, and here, here, plus 3x plus 5. Again, look how many terms there are. There's 4. So this is what we're aiming towards. Now we're going to put together the ones we know. So I wind up with 6x squared plus 13x plus 5. There's my answer there. Okay? And if I continue to multiply these out, I mean, this one, it's just going to be x squared minus 4x minus 7x plus 28, combined like terms. That's a minus. Again, if I just go through and I multiply these, that's all I'm doing.
Is that 28?
Yeah. Minus 4x plus 3x minus 6. Bless you. 2x squared minus x minus 6. Okay? So, notice how our 4 terms, we have like terms in there, and we combine it down to 3 terms. Agree? Okay. So guys and girls, the thing about factoring is I'm going to ask the exact same questions every time we factor. It's not just sometimes. It's not, hey, what are we doing different? But I'm going to start it out. The very first question will always be, what? So our goal, undo what we just said. Okay, great. So my job here is this. Ready? I don't want this one. I'm skipping here. Ready? First question. Greatest common factor. Is there a greatest common factor? Can I factor an x out of all 3 terms here? Be careful. No. Is there a different number I could factor out from all 3 terms here? Can I factor, other than 1, can I factor anything out of 1, 7, and 10? No. So that's always the first question. Second question. Last times first. You're like, what? Let me ask real quick. What number is in front of x squared right now? 1. Does everyone feel comfortable with me putting a 1 right there? Okay. So what is the answer to question number 2 up there? What's the answer to it? Last times first. What's the answer to it? Look up there. What's the... So just the numbers though. 10 times 1 is? 10. Everyone okay with that? Okay. So now, I need to think about this. What are the factors of 10? What times what gives me 10? Well, I know that 1 times 10 gives me 10. Everyone feel comfortable with that? What else gives me 10? 5 times 2 or 2 times 5? Does everyone feel comfortable with that? Okay. So now we have to think about, okay, take a look at our signs. All of them are positive. So the nice thing is, as far as our binomials go, our 2 binomials will be positive. Okay, so that means, because I have this being a positive here, and this being a positive here, that means that both of my factors will both be positive numbers. Okay? Is there anything I have said that is like, whoa, where did that just come from? Feel good about it? Let me go to the third question. So, factors. And then, what factors combine to give middle number? What is my middle number up there on the original problem right now?
7.
Just the number. 7. Okay? Of my factors, when I combine them together, which 2 will combine together, both being positive, that will make it 7? Where are you getting 3 and 4?
Oh, wait, never mind.
Of my factors under the 10, 2 and 5. So here's my factors, right? These are my factors. This is like my toolbox. So if I add 1 and 10 together, I get to 11. Is 11 the same thing as 7? No. If I add 2 and 5 together, is that the same thing as 7? Now watch, real careful. Put your pencil down before you... Don't write anything yet. Ready? So I'm going to bring this x squared down. Still with me? It doesn't matter the order I have these. Okay, keep the signs consistent. Plus 2x. Still with me? Where'd that 2 come from? Right here. Plus 5x. Where'd that 5 come from? Right here. And then I'm going to bring it out my very last term. Make sure all your signs are good. Okay, so what did I really just do? I just broke up the middle term. But it had a certain pattern to it that had to work. I now have 4 things up there. Were we working with 4 things yesterday? If I have 4 things, I go, what do I have in common between those 2? X, and that leaves me x plus 2. Everyone feel comfortable? Then what do I have here? What do I have in common? What goes into both?
2.
2 doesn't go into 5.
Oh.
1 goes into it. 5. Good. Remember that middle sign has to match here. Do we have the same binomial? So I'm going to get x plus 2. What do I have left? X plus 5. So if I were to double distribute this back together, if I were to multiply x to x and x to 5 and 2 to x and 2 to 5 and combine it, I'd get my original. This is how you factor. Guys and girls, this is called the Cherry Creek method of factoring. Not because of this school, but in the 1920s it had been come up with. If you look into any math textbook, they will call it the Cherry Creek method. We just happen to be fortunate enough to be at this school. Do you think it drives Grandview students crazy that their textbook, what is the Cherry Creek method? I love it. Okay. So, I'm going to erase my factors, or I'm going to keep that there. It should be all right. All right, ready? Problem number 2. Do I have a greatest common factor? Can I factor a 3 out of all 3 of those terms? Careful. No. I can't. 3 times some number doesn't give me 16, and 3 times some number doesn't give me 5. Do all 3 of the terms have an x in common? No. So we took care of step 1. What is the last number times the first number? What's the last number times the first number? What? 15. Everyone comfortable? So that's kind of like what we're trying to get to. Okay? So I want to figure out what times what gives me 15. I know 1 times 15 gives me 15. Do you feel comfortable with that? What else gives me 15? 3 and 5. Is there any other whole numbers that you know of that you can multiply together to give you 15? We're good. We have all the factors of it, yes? Okay. See both these signs are positive? That means both of these have to be positive. Okay? Now, here comes that next question. What factors combine together to give me my middle number? What's my middle number on this problem? 16. So, if I add positive 1 and positive 15 together, do I get 16? Yes. If I add 3 and 5 together, do I get 16? No.
Well, 3 times.
Plus.
Oh, no.
Okay? So these are the factors that are going to work here. They're both going to be positive because both those signs are positive. Is everyone good with that? All right, here we go. So 3x squared comes down. Still with me? Plus 1x plus 15x. And that comes down. So all I did is kind of split that up, but I had to make sure I did it in the right order. Okay? So on these first 2 right here, what do I have in common? X. If I factor an x out, if I factor an x out of 3x squared, which is 3xx, I'm left with 3x. Plus 1. Remember, this sign stays as is. What can I factor out of these? 5. That leaves me. Does that work? Okay, so I had 3x plus 1. Let me move this down a smidge. What do I have in common between these now? 3x plus 1. What do I have left? X plus 5. We just factored it. If I were to double distribute, which we worked it on last week, we would get back to 3x squared plus 16x plus 5. Ladies and gentlemen, this is done the exact same way, over and over and over. It's not just sometimes. It's not, hey, if today is Monday, this is the way you do it, but every other day you do it different. It's done the exact same way. If there are not 2 factors that add together or combine together to get you that middle term, that means it will not factor. It doesn't mean there's not an answer. It just won't factor down to 2 binomials. Okay? We okay? Now we have a word of warning. It says, watch those negative signs. So the first 2 problems had both positives. Agree? But think about it. If I have 2 binomials, I can have plus, plus. I can have minus, minus. I can have plus and minus. And I can have minus and plus. Agree? So you got to be cautious on these. What a cute little thing. Oh, all right. So the constant term is positive. So that's the very last term. Okay. I'm just going to move off that. Let's take a look at this. Okay. Problem number 3. Let's start with the exact same question. Do we have a greatest common factor that's a letter or a number? Can I factor an x out of all 3 terms on the number 3? No. Can I factor out a number other than 1 of all 3 terms? No. Okay. Still good? So I'm going to multiply the last term times the first term. What number is really in front of here? 1. What is 12 times 1? 12. So now I want to list all the factors of 12. I know that 1 times 12 gives me 12. I also know that 2 times 6 gives me 12. Yes? And I also know, good, 3 times 4. Okay, so now, we got to be real cautious here. Real cautious. We have different signs up there, agree? We have a negative sign that's on the 7, on the 7x. We have a positive sign on the 12. Okay? So I know that my signs are either positive and negative or negative and negative. It has to be one of those two. Now let's be thoughtful about this. We're going to use a little critical thinking. Okay? If I multiply 1 times 12 and one's positive and one's negative, do I get a positive 12? Ooh, hang on. What about if I multiply a 2 and a 6 together and one's positive, negative? Do I get a positive 12? Careful. What about if I multiply a 3 and a 4 together and one's positive, one's negative? Do I get a positive 12?
Yes.
No. Multiply. If I multiply a positive times a negative. 3 times 4 is indeed 12, but I said if one is positive and one is negative, do I get a positive 12? Okay? So what that means is these won't work. Now, let me ask you this. If I multiply a positive times a positive, is my answer positive? What about if I multiply a negative and a negative? It's also positive. Okay, so these won't work, but these will. Okay, the reason it works is negative 1 times negative 12 is positive 12. Negative 2 times negative 6 is positive 12. Negative 3 times negative 4 is positive 12. Okay, so now we've established that our two factors have to both be negative. Okay, if I add a negative and a negative, it gets more negative, right? Okay, so we've already established that both signs have to be negative. If I combine negative 1 and negative 12 together, I get negative 13. Is that the same as that? No. If I combine negative 2 and negative 6 together by addition, do I get to negative 7? No, I get negative 8. If I combine negative 3 and negative 4 together by addition, do I get to negative 7? Uh-huh. So, here we go. I have my 1x squared, which we're just going to call x squared, minus 3x minus 4x plus 12. Let me pause there for a minute. If I add negative 3x and negative 4x together, do I get to negative 7x?
Yeah.
Yeah. Okay. Do I have 4 terms now? Okay. Let's take a look. Walk through slow. What do I have in common between those two? An x. That leaves me x minus 3. Still with me? Remember, this sign has to match here. So what am I factoring out of this? The negative, first off. What else? 4. So if I factor negative 4 out of negative 4x, that leaves me positive x. If I factor a negative 4 out of positive 12, what happens to this sign? Right? So hang on, let's redo this. Negative 4 times x, negative 4x. Negative 4 times negative 3, positive 12. Agree? And then if I did this, x times x squared, x times negative 3, negative 3x. Do I have something in common between these on the black? Yeah, x minus 3. What do I have left? X minus what? 4. If I were to double distribute on this problem, I get x squared minus 7x plus 12. That's the only combination of the factors that would work. Okay? It's different. It's a whole process that goes with it. You think we're only going to focus a day on this? You think Monday we come in going, all right, now we're going to split atoms? No. Yeah. Well, maybe we will. It'll be kind of fun. All right. How are we feeling? Life good? Life good?
Great.
Okay. Can we get through this number 4? Okay. Item 1. And I'm going to ask the same exact question over and over and over again. Is there a greatest common factor of the 3 terms? Do all 3 terms have an x in it? No. Can I factor a 2 out of all 3 of the terms?
No.
Or any other number other than 1? No. Next step, what's my magical number?
10
Times?
2.
Good. Gives me 20.
Yeah.
Okay? So I know in order to get to 20, when I multiply, I got 1 times 20, right?
Yeah.
2 times 10. Anything else? 4 and 5. Good. That's it. That's it. Okay. So now, notice this. Remember, this was a positive right here, right? This is a negative right here. Agree? Do we have the same here? Are signs the same?
Yeah.
Agree? You like? So what do you think the signs have to be of our factors? Both negative. Awesome. They both have to be negative because a negative times a negative is a positive.
Oh, so then if it was
If this sign right here was negative,
yeah, and
So-
now it's positive.
so B, if this sign's positive, both signs always have to be the same. If this sign's negative, you have positive or negative in some combination.
All right.
Okay? What?
Really.
Okay. All right. So now, both of them have to be negative. Still with me? Both have to be negative. So if I combine -1 and -20, if I add those together, do I get to -9?
No.
No, that's -21. That doesn't work. What about negative?
5.
Does that work?
No.
That gives me -12. That's not -9. But does this work?
No.
Absolutely. Okay, so this is going to be what I'm going to use. Ready? First term comes down, 2x squared. Doesn't matter which order you do it in as long as you keep the signs good. Still with me? What's the next one going to be? -5, and then this comes down to give us
Plus 10.
+10. Oops, I forgot the x right there. Okay, do we feel okay? 4 terms. So we're going to look at our first 2 terms. What do I have in common between those two? 2 and an x. Awesome. If I factor 2x out of 2x squared, what do I have left? X. Minus, if I factor 2x out of 4x, what do I have left? 2. Remember, this sign has to match. So that's negative. What can I factor out of both of those? 5. And it's a -5. So that's, if I factor a -5 out of -5x, it leaves me x. If I factor a -5 out of +10, what happens to this sign? -2. Do I have something the same between?
Yeah.
X minus 2. What do I have left? 2x minus 5. You guys are factoring. Guys and girls, this here is the toughest concept that you will ever see.
How did you get 20?
Because it's the last term times the first term.
So, last term.
So the 10 times the 2. Can I go to the next slide? Does anybody need to like yawn, stretch, poke your neighbor in the eye? How many more slides do I have? I don't even know.
You're done.
That's it?
Not
Oh, I was going to say, holy cow. All right. So, this is going to change things a little bit.
You got 4 minutes.
Hey, B. Remember I told you something? What do you know about that sign?
Stop acting like
So what are your 2 signs got to be? And plus and negative. If that's a positive sign, both signs are the same. They're either plus, plus, or minus, minus. If that's a negative, it's automatic plus, negative. All right. Shh. I can get through these. We good? Can we do it? Item 1 on problem number 5. Is there a greatest common factor? Can I factor an x out of all 3 terms? No. Can I factor any other number out of all 3 terms? Just 1, right? So we're not too worried about that. Okay. So I'm going to take my very last term times my first term. Look at the sign. What's the sign? What's the sign?
Negative.
So if I take my last term times my first term, what do I get?
-12.
Oh, awesome, awesome, awesome. Okay, so 1 times 12, 2 times 6, 3 times 4. How do I get a negative number when I'm multiplying? Does one have to be positive and one have to be negative?
Yeah.
Yep. So I have positive and negative in some order. So let's take a quick look. Is there a way one of my sets of factors, one could be positive and one could be negative, when we combine it together we get to -1, that middle term? Let's see, 1 and 12. Is there any way I could have 1 and 12, when I add them together, one being positive and one being negative, that I get this middle term? What do you think? No. What about 2 and 6? Can one be positive, one be negative when I add them together? Give me -1? No. What about this one? Yeah. Which one has to be negative to get to a -1 when we add it? The 4. Awesome. That has to be a -4, so that has to be a +3. Take a quick look up there. Is -4 times +3 -12? Yes. Is -4 added to 3 -1?
Yes.
Agree?
Obvious.
All right, so those are going to be my factors. So this comes down, I get x squared plus 3x. And again, it doesn't matter. I could have -4x first if I wanted to. It's still going to be the same. -4x minus 12. Still with me? What do I have in common here? And I get x plus 3. Agree? This sign has to match here. What can I factor out of this? If I factor a -4 out of -4x, I'm left with x. If I factor a -4 out of -12, it is +3. Look at that! X plus 3, x plus 3. Whoa! All right.
You're a great teacher.
Your assignment tonight for this weekend, page 51. Okay, it's page 51, 52. I would like you to do number 7, 10, and 13. That's it. Now, guys and girls, I'm giving you 3 problems. They work just the exact same way that we just were doing this. But I want you to try 7, 10, and 13. The reason I only want you to try 3 of them, you don't have this down yet, right?
No.
I don't want you to reinforce if you're doing it incorrectly all the time. So, page 51, 52, numbers 7, 10, and 13. And then obviously that last sheet. Guys and girls, thanks for coming in here on this day. This worked out well. Have a great weekend. Take care of one another.
Have a great day.